Hello, everyone, and welcome back to another episode of Better Together at Science with Sheen Rice, I'd say. Today, we are going to take a step back in our lessons about plate tectonics and go back to the original theory that it was created from, but also to explore the inner mechanisms of the planet and kind of how they operate, right? So, the original theory that plate tectonics is based off of is continental drift, the theory that continents move around on the top of the planet because this part is somewhat liquid, and so these tectonic plates that make up the construction that the continents themselves are based on, well, they move around on top of this liquid part of the mantle until they collide with each other and they're just jostling around and hitting each other. And this theory actually came about in no small part because looking at a map, let me see if I can hold one up here real quick. Looking at a map of the world, right? If you don't notice it, looking at a map of the world, you'll notice that Africa and South America, right? Africa and South America almost fit together like a jigsaw puzzle, right? So, Africa and South America, if you were to push South America all the way over to Africa or push Africa all the way to South America, these two masses would really almost fit together like a jigsaw puzzle. And that is what caused the theory of continental drift to be introduced. Now, at the time that continental drift was introduced, really they had no idea that the inside of the Earth was a molten liquid, liquid rock and super hot, other than the fact that volcanoes spew it up. They didn't know the general diagram of how the Earth operates on the inside. And we don't know for sure that, we have the full understanding. We have a rough guess, and that's the best we can do. But, because we can't cut the planet in half, and we can't dig all the way down to the core, the inner core, and see, we're just kind of left to use some seismic waves and stuff like that to try and figure it out. But the theory of continental drift really started from a guy going, Africa and South America look like they could kind of match up together and be made into one. And it wouldn't be really all that far off. There's almost no difference between the western coast of Africa and the eastern coast of South America, right? But, pardon my allergies too. But continental drift started from that, and then we kind of built our understanding from there. Now we know that there's a semi-molten liquid part called the mantle that is probably the largest as far as sheer width from the crust to the inner core's barrier. The mantle is the largest part of the planet, right? And then you have the outer core is this part that's the green boundary, and then the inner core is the solid red, which the chunk taken out was just to make it so you can actually read outer core. Don't think that I'm actually suggesting there's a bite taken out of the inner core, please. But the crust is probably even thinner, really, if you want to know how seriously thin the crust is compared to the mantle and compared to, inner core, outer core, stuff like that. How seriously thin the crust is, this dry erase marker's line is probably a factor of multiples thicker than what the crust actually is sitting on top of the mantle. That's how thin the crust really is. Okay? Just to put it in perspective. So you have this semi-liquid mantle kind of moves things around because of the flow, because of, current in the mantle. As hotter material moves up to touch the crust, cooler material moves down to get closer to the core where it's once again hotter. It constantly generates a churning motion, right? And so you'll have this churning motion of hot stuff rising and cool stuff falling. And just like with water, just like with any fluid, you'll have a constant cycle of heat rising, cool falling, and generating currents, just like we see in the ocean, just like you'd see in a lake, just like you see with every large body of water. You'll see currents in that water that are just different temperatures of water trying to reach equilibrium, basically, right? But the crust, like I said, with how absolutely astonishingly thin it is constantly just moving around in this liquid that's constantly churning around. Okay, and it's roughly at it's at a roughly steady rate. Although there are some things that would make it accelerate, there are some things that would make it decelerate. So we don't have everything to do with the picture completely figured out, but we have a general understanding from what we currently know. And so this is generally, continental drift is just gigantic plates that sit on top of the mantle, moving around, colliding with each other, and creating new features. Like the Atlantic Ocean was not existent when the dinosaurs first came into being. There was no such thing as an Atlantic Ocean. And by the time the dinosaurs went extinct, the Atlantic Ocean was a legitimate ocean. It wasn't just a, small sea that divided the western half of the continent from the eastern half of the continent, right? It was a legitimate ocean that completely cut off the west from the east parts of the world. And those two parts of the world would not be joined again by anything until the glaciers started to make land bridges possible for animals to traverse across places that were previously submerged, right? So that's basically the gist of continental drift and a basic understanding of the structure of the planet. And like I said, we've used seismic activity and things like that to kind of judge what the Earth's inner structure is like, but we don't have an exact understanding. We can only theorize about it since, like I said, it is way too hot in the mantle. And can you even imagine how hot the inner and outer cores are, right? So, and the inner and outer core are actually responsible for us having a magnetic field, but that's a discussion for another time. Liquid metal flying around a solid metal core creates a magnetic field. But, like I said, that's a discussion for another time. But that should be it for today's lesson, and I look forward to seeing you guys in the next one. If you do have any comments or questions or concerns, please leave them in the comment section below. If you want me to cover a specific topic, please leave it in the comment section below. I read every comment, and I try to interact with all of you guys, and I do greatly appreciate you guys watching. Thank you very much for your time, and I look forward to seeing you guys in the next one. Peace.